Good morning, Math HL students. This is our remote lesson 3, and in this lesson we're going to go over an introduction to differential equations. Alright, so first let's define what a differential equation is, or what differential equations are. A differential equation is an equation that contains the derivative of one or more dependent variables with respect to one or more independent variables. So for example, okay, here's an example of a few. Dy dx equals 2x times y. So y is the dependent variable in this case. There's only one, and the independent variable is the x. So you're told that there's a derivative of some function y is the same as 2x times that function. Okay. X times dy dx equals y minus 1. Y is the dependent, x is the independent. The second derivative of y with respect to x plus the first derivative of y with respect to x plus y equals 0. So in this case, you have one dependent and one independent variable. In the case where you have two independent variables, we have something called partial derivatives, which is basically you hold, if you have a function of two or more variables, to take a partial derivative with respect to one of those variables, you hold everything except the variables you're differentiating with respect to as a constant. Okay, so you can define a differential equation with partial derivatives. So in this case you have two dependent variables u and v. So you have a partial u with respect to y equals to a partial v with respect to x minus partial v with respect to x. In this case you have a partial x with respect to a y plus a partial y with respect to x plus 2 equals 0. And then in this case you have the second partial of u with respect to x plus the second partial of u with respect to t equals 2 times the partial of u with respect to t. Okay, so all of these examples are of differential equations. When you model something with calculus, you are modeling with differential equations. And differential equations, derivatives are a measure of change. And almost always when you are studying a system, what you're studying is how it changes. Because that's the only thing you can really measure. Like if you're studying populations, what you can measure is how a population changes from 1 month to next or 1 year to next, okay? So whatever you're using to describe it inevitably will be describing its change. And it's very similar for all the other things. Like if you pollute a lake and you're measuring how, like oil spill in a lake or something, or in a body of water, you're measuring how that changes over time. Again, you're just measuring change in concentration. So when you're modeling things with calculus, what you're really doing is modeling with differential equations. All right, and but anyway, before we get ahead of ourselves, so types of differential equations. All right, so the same way when you in algebra solve equations, there's different types of equations. Polynomial equations, logarithmic equations, exponential equations, trigonometric equations, and there's different ways of solving them. So we're entering kind of a new branch of mathematics almost here, and there are different types of differential equations. All right, let's go over some of the classifications. All right, ODE. Get ready for a bunch of acronyms. ODE, or ordinary differential equation. It's an equation that contains ordinary derivatives. So the derivatives that we're used to, where there's only one independent variable, okay? So for example, dy dx plus 5y equals e to the x, or, so that's an ordinary differential equation. Or let's say you have a function of x with respect to t and a function of y with respect to t, and the the derivative of x with respect to t plus the derivative of y with respect to t equals 2x plus y. So that's the differential equation. Now with something like that, differential equations are the same thing as regular equations. You have two unknown functions here, x and y. So really to solve this, you would need a second differential equations. If you have two unknown functions, you need two of these, okay? So this is a little incomplete. So yes, there is such a thing as a system of differential equations, which is just, these things get insane out of hand, difficult pretty quickly, actually, as we'll see in a moment here. But the second type of differential equations is PDEs, or partial differential equations. An equation that contains partial derivatives of one or more dependent variables with respect to two or more independent variables. So I think these are examples we looked at in the last slide. But so this would be examples of PDEs. Okay, differential equations are just like algebraic equations in that a handful of them you can solve analytically, and then the rest of them you have to solve numerically. The only difference is solving these things analytically is very difficult, and there's not that many you can solve by hand. Like I took a college partial differential equation class. Well, you have to take a few, but I took one PDE class where like in the whole semester you learn how to solve two of them, basically. Two types of partial differential equations, okay? It's like taking an algebra class and only solving two types of equations, which I think you can, yeah, which you end up doing in Algebra 1 anyway. In Algebra 1, you only solve polynomial equations and maybe logarithmic or exponential equations as well. But yeah, so to solve these analytically, the algebra is just difficult and beautiful, but it's a little bit complicated. Okay, so ODEs and PDEs. Obviously, we're going to focus on ODEs because we've never really talked about partial differentials. So we're going to focus on ordinary differential equations. All right, so the next thing is the order of a differential equation, and this is the analogy would be the degree of a polynomial equation. So the order of a differential equation is the number of the highest derivative in a differential equation. All right, so that makes sense. So, all right, here's a bunch of them. So you have dy dx plus y squared times x equals 2x. The highest order is the first derivative, so this is a first order ODE. In the second differential equations, the highest derivative is the second, so this is a second order ODE. Same thing here, second order ODE. Third order ODE, order differential equations. So in this equation you have two partials, but they're both first order. So this is a first order PDE. You have two partials, they're both second order, so it's a second order PDE, partial differential equation. Okay. There's actually more classifications, but I'll leave those for next time because I just don't want to, we don't need them just yet. So there are even more classifications, okay? Linear or non-linear, where basically you're limited to what you can do with the dependent variable and the derivative. What you can, like, you can't square the derivative, because okay. And then the second thing is homogeneous or non-homogeneous, where it's kind of like the analogy would be writing a polynomial equation in standard form, so it's equal to 0. All right, but so there's more classification. There's two more paths that you can classify them, and then we'll talk about those next time. Okay. All right, so that's the some of the classification of differential equations. All right. We never talked about what you do with differential equations. You solve them, okay? Just the word equation kind of is a hint. So what is a solution to a differential equation? And I kind of hinted on that already. So a solution to a differential equation on an interval a to b is any function y of x which satisfies the differential equation in question. So it's important to know that solutions are often accompanied by intervals, and these intervals can impart some important information about the solution. Okay, so that's obviously true for all equations. So I'm just saying y of x, okay? We're going to solve everything. All the differential equations we solve will be ODEs, ordinary differential equations, and there'll be one dependent and one independent variable, okay? If there's two independent variables, you need two differential equations. Like if you have a function of y and a function of w or something, then you need two differential equations, and then you have a system of differential equations, and then that's a whole different set of topics. Okay, so we're looking for a function. The answer is a function. Okay,